Hi, I'm Nigel Griffiths. In this video we're looking at the Hardware Management Console 8. This is part 3. We're looking at how we can control the virtual machines, or LPARs as they used to be called. Now I'm going to make the assumption that you've been watching the intro part 1 and part 2 for the servers, and otherwise you might get a little bit lost in here. We're using the Hardware Management Console 840, which is the current release, and we're using the classical view to do the control. There are other movies on the Enhanced Plus, but we're not covering that here. Okay, I'll just quickly log in, and here we go. We're going to go to servers again. So here we have all our machines, and we've got this in tree mode up in here, so I can open these little plus signs in here and see all the logical partitions, or virtual machines as they're now called. As we don't need this list over here, we can pop this out of the way, give ourselves some more pixels. And let's open up our two biggest machines here, Ruby. In the previous movie, we quickly started a few LPARs just to show. This one failed to start. That's because this virtual machine in here was relying on two VO servers that I hadn't started. If I click on here and look in Virtual Adapters SCSI, you can see in here it is using two disks on the VO server 3 and 4. And they were here and I hadn't started them, so it could never start up this particular LPAR. This one is actually using a cache disk, so it's using the AX Flash cache feature to give you a massive turbo boost to your my local disks in here. The other one in here that wouldn't start was 34, and that turned out to be my mistake. The boot disk wasn't set properly, and I made a note in here that this is Rail 7.1. You can see here these are the reference codes, normally the LED numbers that are used when starting up an LPAR, and Red Hat puts Linux PPC64 in it. Some of the other operating systems, the Linuxes do different things in here. If I open up, and we can see in here, here's Ubuntu, and they've used PPC64LE. I presume that Red Hat would do a similar sort of thing. This is two copies of Red Hat in here, 7.1. SUSE's those proud to be known as SUSE, so they put the SUSE on the front. And if it's shown on this screen, we know it's PowerPC64, so they don't bother with that. Now, as before with servers, I've selected my columns in here, but I think there's some more information I actually want. So I'll go to this little button up here, a little star against it, so I can add a few. Sometimes it's good to know the number of the virtual machine, as far as the HMC is concerned. Sometimes active profile can be useful. OS version can be very good, although with Linux you have to install the IBM packages to get that to work, and I haven't done that a number of times. We'll see that in a minute. Memory mode, I'll just show you these, they're not so interesting. And then these things are more for the computers rather than the LPARs. There's a bunch more down in here you might want to have a look at and investigate as well. I'll OK that, and we have a bunch more columns in here. So over here we can see we have copies of things like AX 7.2. In here, this is a SUSE Linux, and the details it's giving is about the kernel level. I don't see that's particularly useful in here. On the Red Hat ones, it says unknown. I haven't added the packages to pass that information back. If I go up in here, you can see I've got a whole bunch of different copies of AIX. Actually, I got a copy of AX 5.3 running on this Power 8 machine. I better not tell you any more about that. In here we can see the various levels of the VO server. Oh, notice one in here. There's a 1 missing here. That should be a 1, so that needs an upgrade. I'll have to get around to that after creating my movie. Okay, so let's take this guy in here, and this movie really is about everything we can see in here. The properties onwards, and as we saw last time, we click on here, it's slightly off the screen, tasks, and we get the same list in here. You can choose which way you do that, or indeed you can click here and you get a little menu up here and see the same sort of thing. So we have the operations. This one takes up a lot of screen, so unless you've got a massive great big screen, I probably won't go for that one. Tend to go for this unless, as I said before, if this is right over here, you can't see the button, well you can reach the task up here. So in here, let's have a look at some other things in here, and I'm going to comment on the ones we tend to use a lot. I'll dodge a few of them that aren't so popular in my experience. I mean, that's all I can go by. Okay, so this is the properties of a virtual machine, and if you like, we set up a lot of these when we do a create. I'll probably do that in the next movie. So here we have, we can perform the collection of information about this. This means the HMC can show more information there and collect performance stats. Tend not to use these two. If you're in a highly secure environment, then you may have gone for the trusted platform that checks that people haven't altered the boot disks or the boot disk contents and things like that. And some people like the suspend, where we can halt a CPU, remember where it was, and start it again from the same instruction that it stopped at. I don't tend to use that, but it is there. On the hardware side, let's just grow this a bit. We have the processing units. This number in the middle, of course, is the entitlement that we tend to talk about more than processing units. But we have the minimum and maximums. These are the range where you can slide the actual current entitlement between these two by doing dynamic LPAR changes. And we have the weight factor example uncapped. So we know that this one can go up to 4 CPUs, even though it's only entitled to the 3 CPUs is guaranteed to it. I'm not using on this machine our pools, so that's in the default pool, and we're in Power 8 mode on a Power 8 machine. On the memory side, similar sort of things. It's got dedicated memory. We're not using the AMS in here, so it's got 16 gig, and I can't actually put any more in. That's it, because of the maximum is already set. The huge memory tends to be used by the high performance guys. Maybe some of the database guys might do that. And at the moment, I got active memory expansion is switched off. On the I/O side, this is why I've selected this particular one. This LPAR does actually have physical adapters. These are 2 RAID controllers inside the machine. So this one's using solid state drives. But normally that's not the case. Most of my LPARs or VMs have no physical adapters. They're all in the VO servers. Here's our link to the virtual adapters that go off to the virtual IO server. You can see here's the Ruby 3 and 4. These two are used for the console, sort of dumb technologies, so you can get in if the network's not running or you haven't set it up yet. And we have a virtual network that is connected to the VO servers as well. These 2 connections are giving dual path access to the same disk via the 2 different VO servers. Don't think we got any SRIOV in here. Again, that's probably a different movie. And I forget what's in the settings, to be honest. Yep, just normal things and other. Nothing particularly exciting in there. Okay, let's continue down our list in here. Come back to that one in a minute. Shutdown the restart. They're much the same. The restarts will just stop the operating system and then bring the operating system back up. It doesn't actually stop the LPAR, so if you made changes to your configuration in here, that won't actually get picked up. So let's have a look at shutdown. It does it all the way down. Actually releases all the resources for the virtual machine. Let's drag that back up. We've got different things we can actually do in here. Immediate shutdown means stop the LPAR and it just halts the processor, so no flushing of disks. If you're in open firmware and it's got stuck booting up or something, that's fine, but otherwise not recommended if you've got an operating system down here. We've got shutdown the operating system, which tells the operating system to do its normal shutdown procedure. It does wait, I think it's 5 minutes, so if you've got the time, that's okay, and it does the wall operation and warns any logged in users at a shell prompt. That doesn't help your applications, of course. If you do a shutdown immediate, then it doesn't give the 5-minute warning, it just does a regular shutdown as if you typed in the command, telling it not to hang about or give things any time. Both of those will do an orderly shutdown of your applications, warn the application that's going down and let them tidy up. Nobody seems to use the delayed power off sequence as far as I'm aware. I won't do that because I actually want my machine running to try other things. Okay, next operation down in here, deactivate LEDs. We actually haven't got an LED against this LPAR. If this was an operating system that was reporting errors, like it had a disk drive on a adapter and the adapter failed or something, then we'll have a look at looking at those service events and clearing things down. Of course, just switching off the LED doesn't actually get rid of the error. Just get rid of the annoying little arrows, triangles that we can see hanging about the screen. Next we've got scheduled operations. These are pretty cool actually, and we don't tend to use them here. In production, I think you would. Let's create a new one. We can do things like activate an LPAR or shut one down. So we may have an LPAR that only works at the weekends, for example, to use some spare resources. That would work. Or we could do a dynamic reconfiguration. Take CPUs out of a virtual machine and put them back in, perhaps for Monday morning or something. Let's just use that one as an example. It says when you actually want to do that. That's actually 6 o'clock this morning, so that doesn't help very much. And if you say put in 5 extra CPUs into your virtual machine and there's no 5 available, this window in here will keep retrying for like the next 60 minutes, and as soon as the CPUs arrive freed up, then it'll actually put it into your LPAR. So that's a pretty good way of operating. In here you can say, look, do this every Saturday and Sunday, for example. Click on here, and then we can select which days of the week we actually want to do this operation, and how many times we want to do it. Or you can say, look, let's just do this forever. This is what we want you to always do. And in the options in here, this is for dynamic resources. So we could say processor, add, and then down in here we say how many extra things we want to add to the configuration. And then it will go off and do this forever, and it will appear on that initial list, and we could manage them or switch them off if we wanted to later on. Next up down in here in operations is mobility. Now, we had lots of movies about this feature, and we can do migrate, live partition mobility, validate, or recover if it's got stuck while trying to do that operation. I'm not going to show you the details in here. I tend to go into evaluate because that does a check to see if it's going to work or not. This LPAR has 2 RAID adapters, so we can't do the live partition mobility, but we can show you a failure. Let's go to the other Power 8 machine in here. We can, if the machine was actually connected to a different HMC, actually put the remote HMC and how to log into the other HMC in here. We'll just do a quick validation here. It should say there's ghastly error. There's errors in here because it's using physical slots, exactly the right reason. Okay. Again, that's probably more of another movie to actually show you the details. But if you're pure virtual networks, disks, and DVDs, then you should be able to do live partition mobility. Down in here are the suspend operations. I don't tend to use these, so I won't demonstrate that. Configuration, this is a big important thing. These profiles is what you, well, the initial profile is what you create when you create your virtual machine for the first time. So if we click on here, this one, that's why I chose it, actually has a bunch of profiles. We can see the active profile up in here, normal with internal SSD. That's the one we last activated. If I started the LPAR and didn't select that, then this would be the normally selected one in here. But if we just click on one of these profiles, it'll bring up the details of it, and this looks pretty much like we were looking at the properties, weren't we? The properties of a particular LPAR in here. This is where they're actually getting set when we start the LPAR up. And we've got the similar sorts of details in here. They're laid out slightly differently. We have the I/O, for example, in here. This is for the entire machine. We can see these 2 RAID controllers are the only required ones in here. The rest are the virtual adapters, so that the disks that we're booting off are coming in over here from the 2 VO servers, and we're using virtual network. If you want to change this default profile, it's a bit annoying. You can go in here and say, look, I want to change the default to this one. And then you're thinking, well, how do I do that? Oh, this is one if we've done lots of dynamic changes to our logical partition. We actually want to save that in a new profile. That's how we do that. But if we want to change from the default to the last, this one up in here, the normal with internal SSDs, a little bit confusing. That's the one up in here, so we can change the default. Confuse the dickens out of me for the first time. It knows it's on the default. The other 2 I could change to. Let's actually just do that so I don't get confused if we want to boot that up later on. Okay, and that's operations. Manage profiles. I don't tend to use the other 2. That's similar to what we've just done at a lower level. We've seen already these adapters. See the configuration nicely explained. Dynamic partitioning, pretty important in here. CPUs and memory work much the same, sort of different resources, but operate very much the same way. The physical adapters we can pull into the logical partition. This is dynamic, so it's while it's running we can do these operations. And we can do virtual adapters, so we can create a new virtual adapter to the virtual I/O servers inside the machine and do that. SRIOV, big subject, we'll cover that some other time. But if we quickly look at probably the most common one you actually want to do is the processors. Okay, so at the moment we've got 3 processing units and 4 CPUs that we're allowed to spread across. So we're guaranteed 3 out of the 4 we can actually see. We can see here the maximums are 4 and 4, so I can't go any higher in this. I could take it down a bit. Or I could take this down, take this to 2.5 guaranteed CPU. The weight factor, I could increase that. If we're making drastic changes, particularly with memory, then we'd actually want to give it a bit more time. If we're taking memory out of an LPAR, it has to page it all out and give it. 64 gigabytes of memory takes quite a long time to actually page out, so we can give it an extra threshold so that it doesn't cancel the operation too early. So modifying the CPUs, and we can see here the processing units already changed down to the 2.5, nice and quick. Similar sorts of things happen. The physical adapter is a little bit more complicated because we get that map of everything it's in the box. And if they're not assigned, then we can put them in. Could give it an empty slot, that's really useful. But there's some resources in here that are not assigned. Again, I could click on, what do we got here? Fiber channel adapter, and hit OK. That would arrive. The operating system doesn't know about that. On AIX, you run the config manager and you'll find the extra resources. On Linux, it's a little bit more complicated. Typically, you have to run a script to go and investigate your bus. Right, so we've covered those. Yes, Windows, the consoles or terminals. We can use this open terminal window in here to get a console onto the machine. This is really only of use if you haven't got the network working properly, or you've just installed it and you have to assign the network straight away. The first thing you want to do. On different browsers these work or they don't work. They're called a vTerm, and I find the terminal emulation particularly painful to use, and I don't recommend it to anybody. And what we tend to use, just give you a little example here, is using PuTTY via the HMC to get the console. Okay, so here's PuTTY. You may have your own terminal emulator software for security reasons and things. Okay, so I'll give them a password. Let's hope I can remember that. And in I go. We use this thing called VT menu. And this is the list of machines where we are on the Ruby machine. Here it is, 12. Type in 12, it gives me a list of my logical partitions in here, and 96 is here, so we can hit 9, and in we go, and I can use the dumb console to get in. We tend to use this in the message of the day. It's actually a little program on Linux called Figlet. This will, if we're doing initial install, bring us up the initial installation options, and we can work through and install our operating system that way. Okay, what else have we got? Serviceability. Again, we'll have a different way of doing that by looking for particular machines rather than a particular LPAR with serviceable events. Perhaps I didn't cover it in detail for our virtual machines as opposed to our machines. Here we have the processor, which is the virtual processor number. Then we have the processor units. This is what we call entitlement. We have the memory. This is the ID of the virtual machine itself. More sort of internal, but sometimes useful. You see it on some panels. This is the active profile. In here we tend to have defaults and normals. And you can see us fiddling about with various configurations. Well, I think that's it from the virtual machine side of things. set them up to dynamic operations, and the live partition mobility are all the big hitters for what you want to do with your virtual machines. Right, that's it for this part 3. Next up, we'll be looking at creating a virtual machine from scratch. If you've liked this video, please click the like button below. Thank you.